Hello, good morning friends. Namaste. Welcome to my YouTube channel Industrial Fluid Power. So this channel contains video lectures made by me on this hydraulics and pneumatics subject. My name is C.K. Puranik, professor in Srinagar College of Engineering, Pune. I am author to Tech Neo publication. I have written several books on this subject. Till now I have completed nearly 50 videos, and to complete this subject 50 more videos are required. To do the videos I need motivation. Please give some likes, comments with good words, and share the videos among your friend circle, and subscribe to this channel so that you will get notification when I add any new video. Thank you. We shall proceed to today's topic. Okay, now we shall understand the different possibilities of or different combinations of speed control circuits. Now listen, look here. For extension and for retraction, we used to control the speed. If I keep extension as meter in, I can keep retraction either meter in, meter out, bleed off, or uncontrolled. Is extension of the cylinder is made meter in, and retraction can be made meter in or meter out or bleed off or uncontrolled. Likewise, there itself, okay, 4 different circuits are there. In the same way, I can keep extension as meter out, and I can keep the retraction either meter in, meter out, bleed off, or uncontrolled. So likewise, okay, I can make the combinations. And that too, I can use single flow control valve for controlling the speed of both extension and retraction, or I can use 2 individual flow control valves, one for extension and one for retraction. Likewise, understood. That means I can have different combinations. N number of different circuits are possible, and this is the main problem with students and teachers. Okay, in question paper they will ask, draw meter in circuit. Draw meter in circuit. I can draw say meter in circuit in 10 different ways. Meter out circuit again in 10 different ways. So that's why people should understand this different combinations which are possible while asking the question. Question should be specifically asked. For extension, this type of control is used. For retraction, this type of control is used. One single valve is used or 2 individual valves are used. Everything. If the question is specific and perfect, then for that specific question there will be specific answer. If the question is randomly asked, then n number of answers will be there. So now let us understand this one. How many combinations are possible? Look here. I will keep extension meter in, okay, and retraction. See, extension I am keeping meter in, and I can have 6 circuits. Retraction uncontrolled, or retraction also meter in using a single flow control valve, or retraction is meter in and individual flow control valves are used. For extension 1, retraction 1, 2 flow control valves are used. Again, I can use retraction meter out. Meter in is extension, and for retraction meter out. Again, by using single control valve or by using 2 different control valves. Or extension is meter in, but retraction I can make bleed off. So likewise, I can make 20 different circuits. In these 20 different circuits, there are 10 meter in circuits, 10 meter out circuits, and about 9 bleed off circuits. So 1, 2, 3, 4, 5, 6, and then here this is 7, this is 8, and then this is 9, and this is 10. 10 meter in circuits are possible. Meter out circuit, if I say this is 6 plus 7, 8, and then this is 9, this is 10. 10 meter out circuits are possible. Bleed off circuit, if I take 1, 2, 3, 4, 5, and then this is 6, 7, 8. 8 bleed off circuits are possible. And this much 20 circuit is if it is double acting cylinder. They should tell about type of cylinder or type of motor also. Okay, simply asking the question, draw a meter in circuit. Now, draw a meter in circuit for single acting cylinder, for double acting cylinder, or for unidirectional motor or bidirectional motor. Specific question should be there, then specific answer will be there. Okay, actually, paper setter, only for paper setter I am telling. Paper setter, they won't ask the question, specific question, and evaluator can't evaluate the answer sheets. Okay, now you see this is for double acting cylinder, for single acting cylinder, for unidirectional motor. Again, if I count, for double acting cylinder 20 circuits are possible, for bidirectional motor 20 circuits are possible, for single acting cylinder 6 circuits are possible, for unidirectional motor 3 circuits are possible. Total it is 49 circuits. 49 circuits. I'm going to explain all these circuits in this video, but naturally I have to repeat the same things, same wordings, same sentences again and again 49 times. There is no way. I have to repeat the same thing, and you may get bored about. Okay, same thing if I am repeating again and again. So that's why I will not explain. Just I will show those circuits one by one. Okay, I don't want to explain. Okay, you have already understood everything. Now just we shall see all the different possible circuits. Okay. Look here, speed control of single acting cylinder. Okay, 6 different types are possible. Now in this circuit, oil which is going into the cylinder will flow through this flow control valve. It can't flow through this check valve. Check valve will allow oil in reverse direction like this. It is not allowing oil in upward direction. That's why oil is flowing through this flow control valve. So extension speed is controlled. When I keep the lever in the other position, piston will move back, okay, due to spring tension, and oil which is there here in the cylinder, that will flow through this check valve. So during retraction, speed is not controlled. Okay, during extension, speed is controlled. During retraction, speed is not controlled. There is check valve for free flow. This is one type. Look here, this is the second type. Again, oil which is going into the cylinder, okay, during extension, oil which is going into the cylinder from P to A, it is going to the cylinder, okay, cylinder is extending. This flow is through the flow control valve here. So that's why meter in for extension. When I shift the lever, A to T connection is made, P is closed. Okay, A to T connection is made, and this line doesn't contain any flow control valve. Okay, so retraction is fast, that is uncontrolled. Extension is controlled. Meter in for extension, uncontrolled for retraction. For this itself, 2 types we have understood. First one was like this, okay, and the second one was like this. And this one, look here, I am not using check valve here, let us say. Only flow control valve is there. Then what happens? Okay, in first position, oil is flowing into the cylinder through the flow control valve. That's why it is meter in for extension. And when I shift the lever to the other position, piston will come back due to spring force, and oil which is there here, that is coming out. It is coming out through this flow control valve. Means it is meter out for retraction, meter in for extension, as well as meter out for retraction. So that's what I am telling the second circuit. Look here, meter in for extension and meter out for retraction using single flow control valve. I am using only one flow control valve here. If I close it, the speed of extension and retraction will be reduced. If I open it, the speed will increase. Just by using single flow control valve, I can change the speed of extension and retraction. But I can't keep different speeds as per requirement, okay, for which we are using 2 flow control valve here. This is meter in for extension and meter out for retraction using 2 individual valves, F1 and F2. In first position, P to A connection is there. Oil is flowing from P to A, and it is flowing through this flow control valve F1. It can't flow through this check valve. Okay, it has to flow through this flow control valve F1. Flow is controlled, and here it will flow through this check valve. Okay, oil can flow through this check valve here. So extension speed is controlled by flow control valve F1. When I shift the lever to the other position, cylinder starts retracting. Oil which is there in the cylinder will come out like this, it can't flow through this check valve, it has to flow through this F2 only, and oil will flow through this check valve. Okay, during retraction, the flow is controlled by F2, speed of the cylinder is controlled by F2. Speed of extension is controlled by F1, speed of retraction is controlled by F2. These two flow control valves we are using. And we shall take one more. Look here. Here, this is uncontrolled for extension and meter out for retraction. In first position, oil is flowing from P to A and it will flow through this check valve. Okay, this flow is free flow. That's why cylinder extension speed is not controlled. Means it will extend with higher speed. When I keep the lever in the other position, A to T connection is made and oil which is there in the cylinder will come out. It will come out through this flow control valve. So that's why retraction speed is controlled. So oil which is coming out from the cylinder is controlled. That's why it is meter out for retraction. Next one we shall see. Bleed off for extension and meter out for retraction. So this meter out for retraction I have explained, and for extension, okay, when lever is kept in first position, P to A connection is there, and oil, a part of oil which is flowing out from the pump is flowing back to tank through this flow control valve. Say this is F1. Okay, by operating this flow control valve F1, I can control the amount of oil which is bleeded off, by which I can control the amount of oil which is flowing into the cylinder. So that's why it is bleed off for extension and meter out for retraction. So now this circuit, bleed off for extension and uncontrolled for retraction. During extension, oil which is flowing out from the pump from P to a part of oil is taken back to tank. The remaining amount of oil is flowing to the cylinder. Cylinder speed is controlled. When I keep the lever in the other position, A to T connection is made. P is closed like this. Due to spring tension, piston will come back and oil in the cylinder will flow out. It will flow back to tank. In this line, there is no any flow control valve. That's why the speed is uncontrolled. So understood? So different possibilities are there for single acting cylinder. And we shall see the motor, unidirectional motor. Here also 3 different possibilities are there. One is metered in for forward rotation. Here I can't say, since it is unidirectional motor, I can't tell anything about reverse direction rotation. It can run in only one direction. It can't rotate in the other direction. Unidirectional motor can run in one direction only. So that's why for that forward direction, meter in, meter out, bleed off, likewise 3 circuits we can do. So first one is meter in. I can keep the flow control valve here. No need of check valve because reverse direction rotation is not possible and reverse direction flow is also not there. Okay, oil which is going to the motor is controlled, so that's why it is metered in for forward rotation. If I take here oil which is coming out of the motor, okay, which is flowing out of the motor, so that is controlled here. That's why it is meter out for forward rotation. And this is, I am bleeding off some oil here. Okay, only the remaining oil can flow here, so that's why it is bleed off for forward rotation. So likewise 3 different types of speed control circuits are possible with unidirectional motor. So now we shall come to that 20 different types, that is for double acting cylinders. Okay, so I will show all those circuits one by one. Okay, so now first one, this meter in for extension, uncontrolled for retraction. During extension, this is inlet, this is outlet. Okay, oil which is going into the cylinder during extension is flowing through this flow control valve. It can't flow through this check valve. That's why this is meter in for extension. When I keep the lever in the second position, P to B, A to T connection is made, oil starts flowing to B, and oil which is coming out from A, it will flow through this check valve. It is free flow, that's why the speed is not controlled. It is uncontrolled during retraction. Second circuit, meter in for extension and meter in for retraction. Meter in for both extension and retraction using a single flow control valve. Look here, I am keeping a flow control valve just at outlet of the pump. It may be extension or it may be retraction, whatever it be. Okay, from pump only oil has to flow to the cylinder. Okay. So that's why if they keep the flow control valve just at outlet of this pump, then the flow is controlled. Only controlled flow is flowing to the cylinder during extension as well as during retraction. So that's why extension speed as well as retraction speed both are controlled with the help of only one single flow control valve here. In first position, P2A, B2T connection is there. Oil which is flowing to A port is controlled. Okay, oil which is going into the cylinder during extension is controlled. That's why it is metered in for extension. When I shift the lever to the second position, oil will start flowing to B. From P to B connection is there. A to T connection is there, like this in the second position. Okay, so oil will flow from P to B. It will flow into the cylinder at rod end, and this flow into the cylinder during retraction is also controlled by this flow control valve. So that's why this is metered in for both extension and retraction. This is the second circuit we have completed. Now we shall see the third circuit. Metered in for extension and metered in for retraction using individual flow control valves F1 and F2. In this first position, oil is flowing from P to A and B to T. Okay, oil is flowing from P to A. It is flowing through this flow control valve F1 and it is flowing into the cylinder during extension. So that's why this is metered in for extension. And oil which is there on the other side, it is coming out. It will flow through this check valve. So that's why, okay, this flow is not controlled. Oil which is going into the cylinder is flowing through this F1. The same way, when I keep the lever in the other position, P to B, A to T connection is made, so oil will flow to rod end port through this flow control valve F2. Okay, so that's why this is metered in for retraction. We can control the speed of extension by using F1 and we can control the speed of retraction by using F2. Okay, two individual flow control valves are used to control the speed of extension and retraction. I can keep the speed of extension and speed of retraction different as per our requirement by using these two flow control valves. Are you understanding? So next one we shall take this fourth one. I am not using check valve here, let us say. I am keeping one flow control valve here. Then what happens? Oil which is flowing into the cylinder during this extension, P to A, B to T connection is there. Oil is flowing into the cylinder through this flow control valve during extension. So that's why it is metered in for extension. When I keep the lever in the second position, P to B, A to T connection is made. Oil starts flowing from P to B to rod end port of the cylinder, and from head end of port of the cylinder oil is coming out, and this oil is also flowing through the same flow control valve. So means it is oil which is coming out from the cylinder during retraction. That is meter out for retraction. This circuit is metered in for extension and meter out for retraction by using single flow control valve. Okay, so that is this circuit, meter in for extension and meter out for retraction during single flow control valve. Now we shall say the next circuit, meter in for extension and meter out for retraction using individual valves F1 and F2. This is the circuit. In first position of this valve, P to A, B to T connection is there. Oil is flowing from P to A and then it is flowing through the flow control valve F1 like this. So that's why it is metered in for extension. By operating this flow control valve F1, I can set the speed of extension. Okay, this is metered in for extension, and during retraction what will happen we shall see. We will shift the lever to the other position. P to B, A to T connection is made. Oil will flow from P to B, and oil which is there on the other side of the piston is flowing out. It is flowing out through A, and it can't flow through this check valve. It has to flow through this flow control valve. Okay, so this is meter out during retraction, meter in during extension, and meter out during retraction. Such type of circuit it is. By operating F1, I can set the speed of extension by using meter in method. Okay, during retraction, I can set the speed by operating this flow control valve F2, okay, in meter out method likewise. Okay, so this fifth circuit is over. Now we shall take this sixth circuit, meter in for extension and bleed off for retraction. Okay, see, oil which is in this position, oil which is flowing from, okay, it flows through P to A and it flows through this flow control valve to the cylinder. So that's why it is meter in, and due to this flow piston will extend. So that's why it is meter in for extension. Okay, during retraction what will happen? I will keep the lever in the other position. Okay, oil starts flowing from P to B and A to T in the second position. So oil will flow from P to B and it flows like this, and a part of the flow is diverted back to the tank through this bypass line which contains flow control valve. So we call it as bleed off method. Only the remaining oil will flow into the cylinder during retraction. So this is bleed off for retraction. Got it? Now we shall take the next type of circuit, meter out for extension and uncontrolled during retraction. Okay, oil which is flowing in this position, oil which is flowing into the cylinder, okay, flows through the direction control valve P to A and it enters here, and oil which is coming out, piston is moving from left to right, oil which is flowing out through this B. That oil cannot flow through this check valve, it has to flow through the flow control valve only. The flow is controlled, that's why it is meter out for extension. Meter out for extension. Okay, this meter out for extension. And during retraction it is uncontrolled. You see, we will shift the lever to the other position, P to B, A to T connection is made, and oil will flow from P to B. It will flow through this check valve to the cylinder. So this is free flow. So that's why retraction speed is not controlled. So that's why it is uncontrolled during retraction. And the next circuit is meter out for extension and meter in for retraction by using single flow control valve. Look here, just I am removing the check valve now. If I remove that check valve, what happens? During extension, okay, in first position P to A, B to T connection is there, oil is flowing to A port of the cylinder, piston is moving towards the right, piston rod is extending, and oil which is on the other side of the piston is flowing through this flow control valve. So that's why meter out for extension. During extension, oil coming out of the cylinder is flowing through the flow control valve. Meter out for extension. Okay. When I shift the lever to the second position, P to B, A to T connection is made. That time oil from pump flows to B like this. It will flow through this flow control valve and it flows into the cylinder during retraction. So that's why it is meter in for retraction. Oil which is going into the cylinder during retraction is flowing through this flow control valve. So flow is controlled, speed is controlled. Okay. So retraction speed is controlled by the same valve. Extension speed is controlled by the same valve. Only the thing is, it is meter out for extension and meter in for retraction. Next circuit is meter out for extension and meter in for retraction by using individual flow control valves. Okay, so this is that circuit. Okay, when the lever is kept in this position, P to A, P to T connection is there, oil is flowing to A port of the cylinder, from B port oil is coming out, so that's why piston is extending. And during this extension, oil which is coming out of the cylinder, is flowing through, okay, is flowing through F2. Okay, it has to flow through this F2. So that's why it is meter out for extension. Okay, and oil will flow through this check valve and it will flow back to tank. Okay, when I shift the lever to the other position, P to B, A to T connection is made and oil starts flowing, okay, from P to B and it will start flowing through this F1. Okay, flow is controlled and that controlled flow is flowing through this check valve to the cylinder during retraction. That's why it is meter in for retraction. Got it? So meter out for extension and meter in for retraction by using two flow control valves F1 and F2. So now we shall move to the next circuit. Meter out for extension and meter out for retraction by using a single flow control valve. Now I will keep the flow control valve here, okay, at T port of the direction control valve. Now whether it may be extension or it may be retraction, okay, the oil which is coming out of the circuit is through this T port. It is flowing back to tank. If I keep this flow control valve here, then okay, oil which is coming out of the cylinder during extension is controlled. Oil which is coming out of the cylinder during retraction is also controlled by the same flow control valve, isn't it? So that's why it is meter out for extension as well as meter out for retraction, okay, by using single flow control valve. Now we shall take the next circuit. Meter out for extension and meter out for retraction using two individual flow control valves. So this is the circuit. In first position, oil is flowing from P to A, B to T. Okay, oil is flowing from P to A and it is flowing through this check valve. This is free flow, but oil on the other side of the piston, it has to flow through this, okay, flow control valve here. It can't flow through this check valve. It has to flow through this flow control valve. That means oil which is coming out of the cylinder is flowing through the flow control valve F1 during extension. Means this is meter out for extension. Okay. When I shift the lever to the other position, P to B, A to T connection is made. So oil starts flowing to B port of the cylinder. So this flow, during this flow here, check valve is there. Oil will flow through the check valve. Oil which is going into the cylinder is through check valve, but oil which is coming out of the cylinder, it can't flow through this check valve. It has to flow through this flow control valve during retraction. So therefore this is meter out for retraction, meter out for extension and meter out for retraction by using two individual flow control valves. Now we shall take the next circuit. This one, meter out for extension and bleed off for retraction. Okay. Now in this first position, oil is flowing from P to A, B to T. Oil is flowing to A port of the cylinder, and oil which is coming out of the cylinder is flowing through the flow control valve. So that's why it is meter out for extension. Okay. Oil which is coming out of the cylinder during extension is flowing through the flow control valve and is going to tank. So that's why it is meter out for extension. Okay. When I shift the lever to the other position, oil will flow from P to B and A to T. Okay. Now oil flows to B. Okay. And a part of oil, part of the discharge is taken back to tank, bleeded off. That's why only the remaining amount of oil will flow to the cylinder during retraction. So that's why it is bleed off for retraction. Next circuit is bleed off for extension and uncontrolled during retraction. Okay, very simple circuit it is. Now in first position, P to A, B to T connection is there. Cylinder will extend during this flow. Oil is flowing from P to A and a part is bleeded off and the remaining part of oil is flowing here. That's why rate of flow of oil is controlled and speed of the cylinder is controlled during extension. That's why it is it is bleed off for extension. Okay, and when I keep the lever to the other position, P to B, A to T connection is made. Oil will flow to B port of the cylinder. Oil which is there on the other side of the piston, it will flow back to tank from A to T. So that's why during retraction, speed is not controlled. Uncontrolled for retraction. Bleed off for extension. Uncontrolled for retraction. Okay. So this is bleed off for extension. Okay. The next coming circuits, this will be there. I don't want to repeat again and again. Okay. During extension, oil is flowing from P to A and P to A. A controlled amount of oil is taken back to tank. It is bleeded off. Only the remaining amount of oil is flowing into the cylinder. That's why it is bleed off for extension. Okay. The next circuit is bleed off for extension and meter in for retraction. this is bleed off for extension. Okay, F1 is the flow control valve which is bleeding off that oil. Okay, controlled amount of oil is bleeded off to tank, and that's why remaining amount of oil is flowing into the cylinder during extension. That is why it is bleed off for extension. During retraction, we will keep the lever in the other position. P to B A to T connection is made. Oil is flowing from P to B, and it can't flow through this check valve. It has to flow through this flow control valve. The flow is controlled. Controlled amount of flow is going into the cylinder during retraction. That's why it is meter in for retraction. Okay, bleed off for extension, meter in for retraction. The next circuit is bleed off for extension, but meter out for retraction. So meter out I am keeping here. That's all. Okay. So this is bleed off for extension. Okay. This I don't want to explain. Just in the previous one we have explained. Okay. Meter out, okay, for retraction. In first position, oil is flowing like this, okay. Controlled amount of oil is bleeded off. That's why it is bleed off for extension. When I keep the lever in the other position, P to B, A to T connection is made, and oil is flowing to B, and the amount of oil which is on the other side of the piston is coming out from A. And this oil which is coming out from A has to flow through this flow control valve. Flow is controlled, and hence the speed of retraction is controlled, and hence this is meter out for retraction. Next circuit is bleed off for extension and bleed off for retraction. Both is bleed off for both extension and retraction by using single only one flow control valve. So now look here. I am bleeding off the oil just at outlet of the pump itself. Okay, so therefore the remaining amount of oil is flowing to the system. Okay, for extension or for retraction, only the remaining amount of oil is flowing. So that's why it is bleed off for both extension as well as retraction. Okay, using only one flow control valve. So next circuit is this one. Bleed off for extension and bleed off for retraction using two individual flow control valves. Okay, see here now in first position, oil is flowing from P to A and B to T. Oil which is flowing from P to A is a part of that oil is flowing through F1. Only the remaining amount of oil is flowing to the cylinder. So that's why it is bleed off for extension. I can control the speed of extension by operating this flow control valve F1, and for retraction, I will keep the lever in the other position, second position. In that second position, P to B, A to T connection is there. Oil flows from P to B, and it flows here like this. Again, a part of oil is bleeded off here. So that's why only the remaining oil flows into the cylinder during retraction. So that's why it is bleed off for retraction also. Okay. And the next circuit is uncontrolled for extension and meter in for retraction. Okay, in this position of spool, okay, oil which is coming from pump is flowing to A, P to A, B to T connection is there. Oil is flowing from P to A, it is flowing like this, and oil which is there on the other side of the piston is flowing through this check valve. It is free flow. That's why during extension there is no control over the speed. That is uncontrolled for extension. And for retraction, I will keep the lever in the other position. P to B, A to T connection is made, and oil will flow from P to B, and that flow of oil has to flow through this flow control valve. It can't flow through this check valve. It has to flow through this flow control valve, and that's why the flow is controlled. Oil which is flowing into the cylinder during retraction is flowing through the flow control valve. That's why it is meter in for retraction. And the next one is uncontrolled for extension and meter out for retraction. Okay, look here. In first position, P to A, B to T connection is there. Oil is coming from P to A and it is flowing. It has to flow through it can flow through this check valve. Okay, so that's why the flow to the cylinder during extension is uncontrolled. Okay, that's why it is uncontrolled for extension. Oil is flowing through this check valve which is free flow. For retraction, I will keep the lever in the other position. P to B, A to T connection is made. Oil is flowing to B port of the cylinder, and oil which is there on the other side of the piston is flowing out, and it is flowing through the flow control valve. It can't flow through this check valve. It has to flow through the flow control valve. Oil which is coming out during retraction from the cylinder is flowing through the flow control valve. That's why it is meter out during retraction. Okay, now the last circuit 20. Okay, that is uncontrolled during extension and bleed off during retraction. See, during extension, that is, lever is kept in this first position, P2A, B2T connection is there. Oil which is coming from the pump is flowing to A port of the cylinder, and from B port of the cylinder oil is flowing back to tank. It is a free flow and extension speed is not controlled. Okay, piston will extend, speed is not controlled. For retraction, I will keep the lever in the other position. P to B, A to T connection is made. Oil from pump, it flows to B port here, and part of that flow is taken back to tank, okay, through this flow control valve. Only the remaining part of flow is going into the cylinder. So that's why it is bleed off for retraction. Okay, so these 20 circuits are possible with double acting cylinder. And again, same thing. If I remove this double acting cylinder and if I keep one bidirectional motor like this, okay, I can have all the 20 circuits for bidirectional motor. Okay, so I don't want to explain one by one. It will be just repetition of all those whatever I said previously. So totally 20 plus 20 plus 6 plus 3, total 29, 49 circuits are possible. Okay, for hydraulics. Again, for pneumatics, 49 circuits are possible. If question is randomly asked like this, draw meter in circuit, then think meter in for extension and uncontrolled for retraction. Okay, draw that circuit. If they ask draw meter out circuit only like that, then think it is meter out for extension and uncontrolled during retraction. During retraction, control. They have not given anything for retraction. That's why we can consider uncontrolled for retraction. So likewise, generalize the answer also and draw particular. Okay, thank you.